All right, today's lesson is going to be on points, lines, and planes. The objective is I can identify, name, draw, and apply basic facts about points, lines, segments, rays, and planes. A couple vocab words we need to know. The first one is undefined terms. An undefined term is the most basic figure in geometry, which cannot be defined by using other figures. An example, a point, a line, or a plane. The next term, postulates. Postulates are statements that are accepted as fact or true without proof, and we'll get more into proof later on. Undefined terms. Go ahead and make a grid that looks like this for me, please. A 3x3 grid. I want the term on the left, the name in the middle, the diagram on the right. The first term with its definition, a point, a location with no size represented by a point. I'm going to jump over to the far right for the diagram, and I'm going to draw a picture that looks like this. Now, I have the convenience of different colors, so for me it's easy to say I'm looking at this orange point right here. But if I were on black and white, I would have to name this. And the way we do this is with a capital P. So the way I would name that is capital letter point P. And I don't even need to write the word point. Just a capital letter, we know we're talking about a point. The second term, lines. A straight path of points that extends forever. I'm going to go ahead and draw a diagram it over here on the right. Draw a line. Put 2 points on it. We'll call the point 1x, point 2y. Make sure you have arrows that extend in both directions forever. And I'm also going to put this lowercase capital L up here in the upper right. All right, there's 2 ways to name lines. We can be lazy and use the lowercase cursive letter L, and I would just say line L. Or I can use 2 points, and I can only use 2 points. I don't need 3, I don't need 4, I only need 2 points on the line. I can label it XY. Or line YX, does not matter. Direction means nothing, alphabet means doesn't matter. So both of those are 100% correct answers. The last one, plane. A plane is a flat surface with no thickness that extends forever in both directions. Now I think of a plane as a piece of paper that goes up, down, left, right, and extends forever. It's hard to draw that, so we like to draw parallelograms. A plain old rectangle would be a little bit boring, so we kind of skew it a little bit to give it depth. Go ahead and put 3 points on there, A, B, and C, and also this kind of script capital R. So the two ways I can name it is I can use the capital cursive letter, so I'd say this is plane R, and again I don't need to write the word plane, just use that letter. Or I can use 3 points. For example, A, B, C. And if there's 3 points in any order, I know we're talking about a plane. Some more vocab. Collinear. Points that lie on the same line. An example. Points K, L, and M would be considered collinear. Next vocab word. Coplanar. Points that lie on the same plane. Another sketch of a of a plane. It's a parallelogram, kind of skewing off to the right to show depth. This time I made it go vertical instead of horizontal. And you'll see the points S, T, and U are all on that purple piece of paper. Segments and rays. Make another box like this, a 3x3 grid with term, name, and diagram. In the upper left-hand corner, I'm going to go ahead and put in the word line segment, a line consisting of 2 endpoints. Endpoints I also highlighted because they're important facts, but I did not give them a definition because I kind of think they define themselves in the name. The diagram looks a lot like a line, but it does not extend forever, so points C and D are my endpoints. Now you'll notice there's no little cursive letter, so I cannot use the lowercase cursive letter when I'm talking about segments. So I have to use 2 of the endpoints. So this line segment I would call line segment CD or line segment DC, both correct answers. Next box, a ray. Starts at an endpoint and extends forever in one direction. Here's an example of what it looks like. Starts at point R and extends forever to the left through S, like that. Okay. Now the way I name this messes some people up every now and then. I'm going to name it with the endpoints, but it always starts at the endpoint and shoots through. And you'll notice that up here, even though my ray is going to the left, when I name it to the right, because direction does not matter here. Here's a big mistake people often make. Well, they say, what if I point this ray here to the left and say, well, it starts at R and goes through S. Okay, and that's improper. My ray symbol should always go to the right, because I don't care that this thing goes in this direction. I only care that it is a ray and it starts at R and shoots through S. I'm just naming it. I don't really care if it goes up, down, left, right. None of that means anything to me. So go ahead and say, nope, it will never look like this. Circle it, put a slash through it. Next one, opposite rays. Two rays with common endpoints forms a line. We don't talk that often about opposite rays, because once we have opposite rays, then we have lines, and then we would just say, well, that's a line. But if you were to identify them, here's what a picture would look like. There's point E. I have a ray that shoots this direction forever, starting at E, and I have a ray that shoots this direction forever, starting at E. And I've formed a line there. Here I would just identify it. So one of the rays is EF, and the second ray is EG. And again, you'll notice when I identify rays properly, my arrows are always pointing to the right. Okay, points, lines, and planes. In your notes, please get down these 5 postulates. Through any 2 points, there is exactly one line. Through any 3 non-collinear points, there is exactly one plane containing them. If 2 points lie in a plane, then the line containing those points lies in the plane. And then the postulate's about intersections of lines and planes. If 2 lines intersect, they intersect at exactly 1 point. And if 2 lines intersect, they intersect in exactly 1 line. Excuse me, if 2 planes intersect, they intersect at exactly 1 line. All right, now we're going to do a little diagramming and drawing. So, first part, we're going to sketch 2 lines that intersect in exactly 1 point. And draw 2 lines, have them intersect at a point. You should come up with something that looks like this. And I'm going to call mine point P. Next one, sketch a figure that shows a line that lies in a plane. I'm going to go ahead and draw a line again. It's just a rectangle, but I like to skew it a little bit, turn it into a parallelogram to give it a little bit of depth, to show some 3D to it. So there's my parallelogram. There's a line on it. Sketch a figure that shows 2 lines intersecting in 1 point in a plane, but only one of the lines lies in the plane. So kind of the 2 things we just put together. I'm going to put a plane with a line in it, and then I'm going to have another line shooting through and intersecting at this point right here. Oops. All right, sketch this diagram please for me, and we are going to go through these 4 items here. 2 opposite rays. So if I were to draw on this, here's an example of an opposite ray going in this direction. I beef this line up a little bit. Right there. And here's an example of a ray shooting the other direction. Okay, so my answer would be ray CD and ray CB. And again, you'll notice, since I'm labeling these correctly, that my rays are shooting to the right. I'm not super concerned about CB shooting to the left. A point on ray BC. So here's B, shoots through C forever, and you should be able to identify that D is also on that ray. The intersection, whoops, went a little far, excuse me, the intersection of plane N and plane T. So here is plane N, the purple one, goes vertical like this. Here is plane T, the horizontal one, and they intersect at this line right here. And I would call that line BD, or I could swap the direction and call it line DB. Both the same thing. And then the last one, the plane containing points E, D, and B. Here's E over here, here's D here, here's B here. And it looks like this is the line that contains them. I have two ways I could label this. I could call it line T, or I could use the three letters EDB to label it. Okay, draw the following. A line intersecting a plane at one point. So I'm going to draw a plane, shoot a line through it. A ray with endpoint P that passes through point Q. There's point P, shoot a ray any direction, make sure it goes through Q. And that's it for the lesson.